guys, Mrs. Levenseller here. So once you finish 2.2 solving one-step equations and you've submitted your ALEKS and your practice, we want to look at 2.3, which is solving two-step equations. So now we're adding an extra step to this. We spent a lot of time this past unit, working on PEMDAS and simplifying expressions. So when we start to solve equations, we're going to undo or reverse that PEMDAS, okay? So keep that in the back of your mind when we're solving today. But first, make sure you write down 2.3 solving two-step equations in your notebook. And then the learning target, if you would like to have that, is I can solve two-step equations, meaning instead of just adding or just multiplying to solve for the variable, now we're going to be solving by adding and multiplying, or dividing and adding or subtracting. So there'll be two steps, okay? Same directions as before. Solve the equation, identify the properties used, and check your solution. So let's write down this first example. Example 1, negative 2x plus 3 is equal to 11. All right. So our first step is to isolate this variable, okay? And in order to do that, we have to think about what's happening to the variable. There are two things happening. One is that we're adding 3. The other is that we're multiplying by a negative 2. So if I'm trying to isolate x, I need to remove both the 3 and the negative 2. And I'm doing that by reversing my PEMDAS, right? So that means I want to start by adding and subtracting anything away first. So that I see there's a plus 3 that's been added on to the x. So I'm going to use my subtraction property of equality and subtract 3 from both sides of the equation. Notice I'm doing it to both sides of that equal sign, right? Treat that like the bar that we did with your algebra tiles. We're subtracting from the like term, okay? So negative 2x gets brought down. Positive 3 and negative 3, the reason we did that is that they're inverses, so they give us 0, so that crosses out. And 11 minus 3 is 8, okay? So that was one step, but I'm not done solving until this variable x has been isolated. So next I have to see if there's any multiplication or division to undo, and I see that we've multiplied negative 2 by x. Well, the inverse of multiplying by negative 2 is dividing by negative 2, and whatever I do to one side, I must do to the other. Negative 2 divided by negative 2, those would cancel out, and I'm just left with 1x, which is really just x. That's equal to 8 divided by 2 is negative 4. So 2 steps to solving. We did the subtraction property of equality, and down here we did the division property of equality, right? We can check our answers in the same way as we did before by substituting. So if our equation is negative 2x plus 3 is equal to 11, I'm going to substitute in negative 4. And then actually do the PEMDAS on the left side. So negative 2 times negative 4 is 8. Oops. And 8 plus 3 is, in fact, 11. So we did that correctly. Okay. Want to look at one more example with you. Oops, which I accidentally had the answer to. Let me delete that and we'll start over. So write down the second example. X over 4 minus 7 is equal to 1. So when I start solving, I'm trying to isolate the variable. And I see two things happening to it. The first is division by 4. And the second is subtraction by 7, right? Well, with solving, we want to undo any addition and subtraction first. So the opposite of minus 7 is adding 7. Those are inverses, and whatever I do to one side, I'm doing to the other. So now I have x divided by 4. Negative 7 and positive 7 cancel. That's now just going to be equal to 1 plus 7, which is 8. So that was my addition property of equality. Feel free to abbreviate those. Now I look at my x And the only thing left is it's being divided by 4. Well, the opposite of dividing by 4 is multiplying. So I'm multiplying by 4 on each side. And you can put that over 1 if that's helpful, but 4 divided by 4, those two things end up canceling and just leaving us with 1. That's why we're using the inverse. So on the left side, I just have 1x, which is really just x, right? On the right side, I have 8 times 4, which is 32. All right, that was my multiplication property of equality. Okay, if I want to check it, I'm going to substitute back in. So 32, where the x goes, over 4 minus 7 is equal to 1. PEMDAS tells me to divide first, so 32 divided by 4 would be 8. 8 minus 7 does, in fact, equal 1. So we did it correctly. Okay, so when doing your assignment, please show out your steps and do the check for these. I won't always make you do the check, but it's really good to get in the habit now. Okay, so go ahead and try your 2.3 practice.